All right, so you've noticed that we've seen some Venn diagrams for most of our common set operations, except we haven't done a difference yet. So let's try the Venn diagram for A minus B. Notice I just have two sets. So I could have two circles. So my big rectangle is labeled U, one of them is labeled A, and one of them is B. And then notice we have to think about what the definition for that difference was. And it was A minus B was it's in A, but it's not in B. So literally in my picture then, I need to be a part of the circle A, but not a part of the circle B. So I need to be inside of the circle for A, outside of the circle for B, and all that leaves is this sort of crescent moon-shaped region. So notice, inside of A, but outside of B would be our difference Venn diagram. Now the next thing that we can do with Venn diagrams is we can, again, like we did with set operations, we can do more than one operation in a single problem. And the way we're going to do it is likely one step at a time. Potentially, we might be able to see more than one, all in one step, but a lot of times doing them one step at a time will be easier, especially in the beginning. So thinking about something like the Venn diagram for A union B complement, well, let's think back to when we did A union B complement with numbers, with not necessarily numbers, but elements, with specific elements in our sets. Well, we first found A union B. So let's do the same thing here. So first we find A union B as a Venn diagram, which remember when we're doing A union B, we lump them both together, so we're in either A, so we're in A or we're in B. Or is a good word to use for a union. So in A or in B. And then now we need to take that set and find its complement. Now remember, the complement is essentially the opposite. So when we're doing a complement of a Venn diagram, we're going to do the opposite shading. It's sort of like if you take a look at a picture and then you do the negative of that picture, right? All the lights and the darks flip-flop in the photo because I want to now be not in this thing. So I want everything over here. I want to get rid of anything that was shaded and now have anything that wasn't shaded. So I'm going to draw the same start Venn diagram. And if I take a look at wanting the opposite of this picture, well, now I don't want A or B shaded. I only want what was outside of them shaded. So the two shadings flip-flopped for the complement. Now notice, doing the sequence of pictures hopefully was helpful to see how that would work. Let's look at the next one. So reading the next one across would say we want A intersected with B complement. So we need a couple of different things for this picture. Let's first draw a picture just for the set A. Now, all together, I eventually will need two circles, so I'll draw both. And if we think about it, well, the thing that represents set A is the circle for set A. So the entire circle will be shaded. Now, let's do one for B complement. Again, let's do 2 circles since eventually I need to combine the 2. So the A and the B. Remember, B complement, like we talked about in our other example that was in the worksheet, we want everything outside of B. And that includes all the things outside of B, which includes the box. So the only thing left unshaded is the circle B itself. Now what we need to do in the next picture is we need to take these 2 pictures and find the intersection between them. So we're going to come over here and we're going to look for A intersect B, complements. And we need to think again about what does an intersection mean. Now, an intersection is the overlap. It's what is common to both of them. So what's in the first picture and in the second picture. So let me first just draw the circles. Got A, and we've got B, and we've got a rectangle for U. Now, if I look at both pictures, we can go region by region if we want. We can look at, well, should I shade the box? Well, no, because it's not shaded in the first picture, right? In this picture, it's not there, so it's not common to both. Should I shade the circle A? Well, we need to be careful because there's really 2 pieces to the circle for A. Notice this one has both pieces shaded, but this one has only one of them shaded, not the overlap. So this outside portion for A is shaded in both of them, but not the middle region. And then notice the portion inside of B is not shaded in either of them, so we shouldn't shade it here either. So all we kept was that portion that was inside of A, but not inside of B would be my final picture. Now, we might notice an interesting thing that we're going to talk about in one of our next videos, where if I take a look at all these examples we did, they're not all the same, but the final result for the first example and the last example was the same. Notice both of them only have that sort of crescent moon part of A, which means that they contain exactly the same elements, which means those sets are equal to one another. So that's an application of Venn diagrams that we're going to use, and we'll do an example of that in particular in a later video, but just keep that in the back of your mind for now, that we can use these Venn diagrams to help us see what set operations are equal to one another. Before we do that though, I want to look at one other application for Venn diagrams. That's just another way to picture them. In this one, I have 3 different sets, a set U, the universal, and then an A and a B, and I actually know what elements are in those sets. Notice in all of these other examples we've been doing, it doesn't matter what the elements are, they're just random, arbitrary sets as opposed to specific sets. So what I want to do in this example is draw a Venn diagram and actually label the elements in their particular regions. Put them in the regions where they would go. So let's draw a Venn diagram. What does it start with? Well, it starts with a big rectangle. And then in this one, I just have 2 sets, A and B, so we can just do 2 circles, A and B. And as we take a look at these now, what we're going to do is we're going to go element by element and figure out where it goes. So if I look at, say, the element A, we see, well, it is in my universal set, and I also see that it's in set A. We look then though and see, is it in set B? And the answer is no. So it's only in A and not in B. So the particular region in my diagram that represents that is this region right here, right? We're inside the circle for A, but outside of the circle for B. So my little element A fits in that region. Looking at element B, it's not in A, but it is in set B. So it's going to go inside of circle B, but outside of circle A. Same with element C. Element C is in B, but not in A. So that also fits in this region. We can write it wherever we want in there. Taking a look at our next element D. D is in both A and B. So we need to find a region that's inside of A and inside of B. It's in the overlap between the two. So that's going to fit right here, element D. And then the last one we see is element E. It's in the universal set, but it's not in A nor in B. That's why we have this portion outside of the two circles, right? It needs to be outside of the circle for A. It should not be in the circle A. And it should not be in the circle B. It needs to be outside, which leaves it in the box. Now what's cool is when we take a look at this and put it all back together, we can visually see these sets and what elements were a part of them. Right, literally everywhere in the universal set, if we look at everything inside the box, I see A and B and C and D and E. Right, they're all there. They all show up. And if I look just inside the circle for A, notice it's two elements are both there. Both A and D are in the circle. And if I look at the full circle for B, all of its elements are there. We've got B and C and D. They all show up, and they show up in their particular region. So we've been able to write every element only one time, but place it where it goes in the region. So that might also help you see the visual nature of what these regions represent, of being representing elements in certain sets and outside of other certain sets. What we're going to do next is, again, you're going to go to your worksheet and you're going to work on the problems in the next 2 videos, I believe it is, and take a look at those. So again, give them a try on your own first and look at the video if you need a push or once you're ready to look at the full solution. And then when we come back to working at the board, I'm going to talk about this idea a little bit more.